Have you ever questioned the nature of reality? Does it remain the same whether we observe it or not? These are the questions that quantum physics seeks to answer, and the answers might just shatter your perception of the world. Take the double slit experiment, for instance. It's an experiment that unfolds the bizarre behavior of tiny entities like photons, which don't seem to abide by the rules of classical physics. Prepare to have your mind bent a little as we delve into the strange and fascinating world of quantum physics. Imagine a machine that shoots tiny balls of light, or photons, at a wall with two narrow slits in it. Behind this wall, there's another one, equipped to detect where these photons land. Now, if we were living in a simple, predictable world, you'd think that these photons, much like bullets from a gun, would pass through the slits and create two distinct bright spots on the second wall. This would be the logical expectation, right? However, the world of quantum physics is far from simple. Instead of two bright spots, the photons create an intricate pattern of alternating bright and dark stripes on the second wall. It's as if they're not particles at all, but waves spreading out and interfering with each other, creating regions of high and low intensity. This unexpected result is known as an interference pattern, but in the quantum world, things don't always behave as you'd expect. Instead of two bright spots, the photons create a pattern of many bright and dark stripes like waves on a pond. This is where things get incredibly fascinating. We're in the realm of quantum physics now, where the ordinary rules of the universe that we understand seem to get thrown out of the window. Instead of behaving like tiny balls of light, which we might expect, these photons are behaving like waves. They're spreading out after they pass through the slits, overlapping and interfering with each other. This creates regions of high intensity and low intensity, a phenomenon we call an interference pattern. It's as if the photons are going through both slits simultaneously, like a wave would. But wait, didn't we say that photons were particles? Indeed we did. And this is where we encounter the principle of wave-particle duality in quantum physics. It's a bit of a mind-bender, but it's as if these particles of light, these photons, can be both waves and particles at the same time. It's a concept that's as strange as it sounds, and it's one of the reasons why quantum physics is so wonderfully perplexing. It tells us that things at the quantum level don't behave in the way we might expect them to based on our everyday experiences. But what if we try to observe these sneaky photons in action? Opening. The moment we observe the photons, the pattern changes. Now let's dive into the peculiarities of this experiment. You'd think that observing the photons wouldn't make a jot of difference, right? Wrong. When we observe the photons as they pass through the slits, they cease to behave like waves and revert to acting like particles. Instead of creating an intricate interference pattern, they travel through one slit or the other, hitting the second wall and creating two bright spots. This is where the concept of the wave function collapse comes into play. The photons, it seems, have an array of possible paths, but the act of measurement, of observation, forces them to choose one. It's as if all the potential realities collapse into a single, tangible outcome the moment we peek at the photons. Closing. So does this mean that reality changes when we observe it? The double slit experiment reveals a quantum world full of possibilities where nothing is certain until we observe it. This experiment, as simple as it may seem, uncovers the paradoxical nature of light and matter. It introduces us to the concept of wave-particle duality, where photons and other subatomic particles exhibit the characteristics of both particles and waves. The most intriguing part, however, is the observer effect. The act of observation, of trying to pin down the path of the photon, forces it to behave like a particle, to pick one path over another. It's as if the photon knows it's being watched. In the realm of the quantum, reality is a game of probabilities. It's a world where light can be both a wave and a particle, where things can be in multiple places at once until we look. This experiment challenges our common sense and intuition, leaving us with a sense of wonder about the nature of reality.